Dear students, today we shall do a problem. Find the amount of heat transfer through a fin of thickness 5 mm, length 50 mm and width 100 mm. Also determine the temperature at the tip of the fin. The atmospheric temperature is 28 degrees Celsius and the temperature at the base of the fin is 80 degrees Celsius. The convective heat transfer coefficient is 11 watt per meter square Kelvin and the thermal conductivity of the fin material is 58 watt per meter Kelvin. The end of the fin is insulated. So this is a rectangular fin, straight rectangular fin. Then the second one is the end of the fin is insulated, that is the short fin and insulated type. So this is the base of the fin, this is the tip of the fin. So this is the length 50 mm, the width 100 mm, the thickness 5 mm. So that is written here. So what is perimeter? Perimeter is 2 into W plus T. You convert into meter. Area of cross section, rectangular section. So W into T, we get 5 into convert into meter square. Now in the problem it is given the temperature at the base TB is 80 degree Celsius. What is the atmospheric temperature? That is T infinity. T infinity is 28 degree Celsius. Now we have to find out the heat transferred through the fin. For that, from the data book. So from the data book, page number 50, type of fin. The question is short fin and insulated. Heat, first column is temperature distribution, second column is temperature distribution, third column is heat transferred by the fin, say Q suffix F. What is the equation? Root of HP Ka TV minus T infinity tan HML. So that equation is written here. Value of H is given, then H is 11, perimeter here, area of cross section, TB, T infinity, length, we have to find out M. What is the equation for M? Root of HP by Ks. It is also given in the data book. M is equal to HP, root of HP by Ks. Substitute the values, we get the value of M as 8.925. Now you substitute the values in this equation. So to find tan HML, you take the calculator, we take press hype. So we get sin h, cos h, tan h, sin h inverse, etc. So tan h is 3. So press 3 tan h. What is M? M is 8.925 into L, 0.05. So we get the value. So we get the value of the heat transferred as 5.64 watt. So this is the first part of the question. Now, second part is you have to find out the temperature at the tip of the fin. To find the temperature at the tip of the fin, take the data book. Take the data book, say here, it is given end insulated, temperature distribution T minus T infinity by TB minus T infinity is equal to cos HML minus X divided by cos HML. And we have written the equation here, T minus T infinity by TB minus T infinity is equal to cos HML minus X divided by cos HML. What is T? T will be the temperature corresponding to the value of X. We have to find the temperature at the fin tip. At the fin tip, that is X will be equal to L, that is equal to 50 mm, that is 0.05 meter. So in this equation, T infinity is given, TB we know. Substitute the value of X is equal to 0.05 meter. From that we get the value of T. That is, for a value of X is equal to 0.05 meter, we get the temperature T. If you want to get the temperature at the fin at x is equal to say 0.01 meter. You put here x is equal to 0.01 meter, we get the value of T. So to find the temperature at any point in the fin, put the value of x at that point in this equation number 1, we get the value of T. Second problem. A very long copper rod 5 mm diameter has one end maintained at 100 degrees Celsius. The surface of the rod is exposed to ambient air at 20 degrees Celsius with a convection heat transfer coefficient of 100 watt per meter square Kelvin. Determine the temperature distribution along its length. That is, we have to find out the variation of temperature along the length of the fin at different values of x. This is a long fin, so L tends to infinity. So this is a circular type fin, so D is 5 mm. Again, maintained at 100 degree means the base temperature is Tb is 100 degrees Celsius. Ambient temperature, so T infinity is 20 degrees Celsius. Convection heat transfer coefficient is given, but here the thermal conductivity is not given. So we have to find the value of thermal conductivity from the data book. That is, to find the thermal conductivity, copper rod. So we have to find the value corresponding to the mean temperature, 100 plus 20 by 2, 60 degree Celsius. So we have to take the property values, say from data book, say page number 2. So it is given in page number 2, say property values of metals at 20 degree or above. So the first column, the metal is type of metal is given. Second column, density, thermal diffusivity is given, and in the last column, thermal conductivity is given. So what is our material? Our material is copper. So here we can see copper pure, and the value of thermal conductivity is 386. So we get the value as K is equal to 386 watt per meter Kelvin. Now for a long fin, very long fin, say what is equation for? We have to find the temperature distribution, which means we have to take this equation T minus T infinity divided by Tb minus T infinity is equal to e raised to minus mx. So that is the equation. This equation, you write T minus T infinity is equal to T by Tb minus e raised to minus mx. So we can write T infinity is equal to 20 degree, Tb is 100 degree. What is m? Hp by k into ac. Circular rod, so area of cross section is 5d square by 4. Perimeter is 5 into d. Substitute the values, we get m is equal to 14.4. Now substitute in this value, here t is equal to T infinity plus Tb minus T infinity and e raised to minus mx. T infinity is 20 degrees Celsius. Tb minus T infinity is 100 minus 20. So we get it as 80 into e raised to minus 14.4x. Now you put different values of x, we get the corresponding value of temperature. That is, we plot a graph Tx. You put say x is equal to 0.01 meter, or you put x is equal to 0, you get it as 100. Then you put another value, put different values, and you plot the graph. You will get the temperature distribution. Now the second part of the problem. In the above problem, how long the rod must be for the assumption of infinite length to yield accurate estimate of the heat loss? That is, from the data book, we can write the equation for a long fin. What is the heat transfer? The heat transfer is Qf is equal to Tv minus T infinity Hp Kr raised to root of Hp Kr. Similarly, for a short fin end insulated, it is also in the data book, we get Tb minus T infinity the root of HPKIC tan HML. So you compare these two equations, that is the equation for a long fin and the equation for a short fin end insulated. C TV minus T infinity. So the only difference there is the value of tan HML. Tan HML. So we make an approximation. That is the equation for long fin can be written as TV minus T infinity in the root of HPKIC provided tan HML is greater than or equal to 0.99. So this is an approximation. So tan HML is greater than or equal to 0.99 means ML is greater than tan H inverse 0.99. Then the calculator you take see tan H inverse is given in 6. So plus 6 tan H inverse 0.99. From that you get the values around 2.6465. So we can write ML is greater than or equal to 2.65. What is M? We have already calculated. M is equal to 14.4. That is, from that we can write 14.4 into L is greater than or equal to 2.65. L is greater than or equal to 2.65 by 14.4 and we get 0.184 meter. That is, once the length crosses 0.184 meter, the fin becomes a long fin. So actually, considering the design parameters etc., it is not possible to make very long fins. So 99% of the heat transfer can be achieved by selecting M into L is equal to 2.65. So from that we get the value of L. L is equal to 2.65 by M, which means L greater than 2.65 by M makes no sense. So okay, thank you.